We can now put together everything that we've learned into a complete picture of the atom. So let's just review. The atom is made up of electrons, protons, and neutrons. Minus 1.6 times 10 to the minus coulombs, plus 1.6 times 10 to the minus 19 coulombs. No charge. The mass is very light, 1 over 1,800 AMU, around 1 AMU, and around 1 AMU. And when you look at this data, it's a little surprising. And it's surprising because of the Rutherford experiment. The Rutherford experiment showed that the massive particles were very, very small because the alpha particle bounced back rarely. The protons and the neutrons were in the nucleus and very small. And the surprising thing is this. The small thing is the heavy thing. The nucleus has got all the mass at 1 AMU, and the light thing is the big thing. The electron, which is the rest of the atom, is 1 over 1800 AMU. And I think you can make, when you want to look for an analogy, what I think of is, an elderly person, and here's the elderly person, and not moving very much, very massive, and then running around it is a small child just running around like crazy. So here's the small child running around like crazy. Here's the child. And here's the heavy center. That's actually a pretty accurate picture of the atom. A long time ago, they wanted a very orderly world, so they decided, okay, you're going to have a heavy center, they decided to impose order on it, so they would make the electrons move in fixed orbits, sort of like the sun and little planets moving around it. So they wanted an orderly universe where they were going to, this is the Planetary Model. And for a long time, because I guess we liked order, there was no reason to, I guess there were some reasons to believe in the Planetary Model. But it turns out a more accurate picture, a more modern picture, is this one, where the electrons moving around like crazy, following its own laws of quantum mechanics in things called orbitals. Okay, that's the pictures, and now let's get to a little nomenclature. Ordinary hydrogen. Ordinary hydrogen is 1 electron and 1 proton. And the way you're going to write it is like this. First, you write hydrogen. And in this corner here at the lower left, we write the number of protons. So here we write number of protons. This is the element symbol. And in the upper, on the left side on top, we write the number of protons plus the number of neutrons. So ordinary hydrogen has no neutrons, and so the sum of the protons and the neutrons is 1. The number of protons is 1 for hydrogen because it only has 1 proton. Any atom with just 1 proton is going to is in this family, and this is the element symbol. And then we can look at the unusual hydrogen, the 0.02% hydrogen, and it has still 1 electron and 1 proton, and it actually has 1 neutron, and so its symbol here in this corner will be still 1 proton, but here in the upper left, it's the number of protons and neutrons. That's 2, because it's the number of protons plus the number of neutrons, and they are called, this version of hydrogen is called deuterium. There is one other kind of hydrogen known, which has 1 electron and 1 proton and 2 neutrons. So 3H1, it's called tritium, it's radioactive. And these are the element symbols. And there's we keep on upping the element symbols. Let me tell you about one more corner. So here's my regular hydrogen. It's got 1 proton, and a neutron, and it's made up of 1 proton plus 1 electron. If it loses the electron, then it acquires a net charge. A net charge of +1, and we put the charge up here. So this symbol here, with all these things around the H, a 1 in the lower counter, a 1 in the upper right, and a 1 plus, is the same thing as a proton. One more thing. Because the letter tells you already the number of protons, if it's a hydrogen, it's got 1 proton. Very often we omit the lower symbol. So we can write 1H or 2H or 3H for hydrogen, deuterium, and tritium. Let me just give you one last application. The alpha particle. The alpha particle is made up of 2 protons plus 2 neutrons plus 0 electrons. And so figure out what its symbol, its element symbol is. And you need to know that the element with 2 protons is helium. So work that out and we'll share answers in just a second.